Hello everyone! We are the reporters for gas laws.
Bonjour, je m'appelle Alia. I am the reporter for Boyle's Law.
Hola amigos, me llamo Jonah. I am the reporter for Boyle's Law.
안녕하세요. 저는 Queenie I'll be reporting about Gay-Lussac's Law.
Ni hao, Wotiao, Sam Capulong, and I'll be reporting about Avogadro's Law.
Konnichiwa! Watashi no namae wa Fiestada Rina desu. I'll be the one to help you learn the basics of the ideal gas law.
Maligayang bati, ako si Joseph Lucena, and I will give you a SIP word.
Robert Boyle was best known as a natural philosopher, particularly in the field of chemistry. He was born in County Waterford, Ireland on January 25, 1627. In 1659, he and Robert Hooke completed the construction of the famous air pump and used it to study pneumatics. This led to discoveries of several physical characteristics of air, including its role in combustion, respiration, and the transmission of sound. One of their findings, published in 1662, later became known as Boyle's Law, which aided in the invention of syringes and explains the science behind balloons, plane travel, and etc. Boyle's Law expresses the inverse relationship between the pressure and the volume of a gas if the number of molecules and the temperature are both constant. The relationship for Boyle's Law can be expressed as follows. P sub 1 times V sub 1 is equal to P sub 2 times V sub 2.
Also known as the law of volumes, Charles' law is an experimental gas law which describes how gases tend to expand when heated. It states that if a given quantity of gas is held at a constant pressure, its volume is directly proportional to the absolute temperature. It was first published by French natural philosopher Joseph Louis Gay-Lussac in 1802, although he credited the discovery to unpublished work from the 1780s by Jacques Charles, hence the name. Jacques Alexandre César Charles was a mathematician and physicist remembered for his pioneering work with gases and hydrogen balloon flights. Charles was born on November 12, 1746 in Beaugency-Loret, France. His first occupation was a clerk.
The formula for Charles' law is V sub 1 over T sub 1 is equals to V sub 2 over T sub 2, where V is volume and T is temperature.
Joseph Louis Gay-Lussac was born on December 6, 1778 in France. He was a chemist and physicist who proposed two fundamental laws of gases in the early 19th century, the Charles law and the Gay-Lussac's law. Gay-Lussac's law shows that increasing the temperature of a gas causes its pressure to rise proportionally when the volume is constant. Similarly, decreasing the temperature causes the pressure to fall proportionally.
Amadeo Avogadro was an Italian scientist of the 19th century. He is known for making major contributions to chemistry when it was just becoming a separate science field. His work came around the same as that of Jacques Charles, Robert Boyle, etc. Avogadro's law states that under conditions of constant pressure and temperature, there is a direct relationship between the number of moles and volume of a gas. This was Avogadro's initial hypothesis. The formula for Avogadro's law is V over N is equal to K.
Ideal gas is defined as one in which all collisions between atoms or molecules are perfectly elastic and in which there are no intermolecular attractive forces. One can visualize it as a collection of perfectly hard spheres which collide but which otherwise do not interact with each other. Moreover, an ideal gas can be characterized by three state variables: absolute pressure, volume, and absolute temperature. This is where the ideal gas law makes its appearance. Referred to as the general gas equation by some, the ideal gas law is the equation of state of a hypothetical ideal gas. It is a good approximation of the behavior of many gases under many conditions, although it has several limitations. It was first stated by Emily Clapeyron in 1834 as a combination of the empirical Boyle's law, Charles' law, Avogadro's law, and Gay-Lussac's law. The ideal gas law is often written as PV is equal to nRT, where N is the number of moles of gas and R is the ideal gas constant. It is the same for all gases.
After discussing the different gas laws, we're going to tackle about now our seat work. This consists of the problem-solving area of gas laws. The first problem is about the Boyle's law. The problem is, if 12.5 liters of neon at 846 millimeters mercury are compressed to 725 millimeters mercury at constant temperature, what is its new volume? Using the formula P sub 1 times V sub 1 is equal to P sub 2 times V sub 2, you have to solve the new volume. The given are 12.5 liters of neon, which is equivalent to the first volume, 846 millimeters mercury, which is equal to the first pressure, and 725 millimeters mercury, which is equal to the second pressure, and we are tasked to find the new volume. Using the formula V sub 2 is equal to P sub 1 times V sub 1 all over P sub 2. Just multiply 846 millimeters mercury to 12.5 liters of neon all over 725 millimeters mercury. Do you know the answer? The answer is 14.59 liters of neon. The second problem is all about Charles' law. If 32.1 liters of nitrogen at 25.85 degrees Celsius is allowed to expand to 43.2 liters, what will be the new temperature in degrees Celsius? Using the formula V sub 1 all over T sub 1 is equal to V sub 2 all over T sub 2, we could find the new temperature in degrees Celsius. But using the Charles' law, the formula or the standard unit for the temperature is Kelvin. In order to find a new temperature, we must use the formula T sub 2 is equal to T sub 1 times V sub 2 all over V sub 1. But we must change first the temperature, which is in degrees Celsius, to Kelvin. After that, we must continue our solution. 299 Kelvin multiplied to 43.2 liters all over 32.1 liters will come up to the answer 402.39 Kelvin, but this is not the final answer. We are tasked to find the new temperature in degrees Celsius. So 402.39 Kelvin is converted to 129.24 degrees Celsius, and 129.24 degrees Celsius is our new temperature. The third problem is all about Gay-Lussac's law. In an oxygen tank reads 920 millimeters mercury at the surface of a lake, where the temperature is 300 Kelvin. If a diver used this to dive down to the bottom of a lake, and the temperature drops down to 122.78 Kelvin, what will be the new pressure of the tank? Since Gay-Lussac's law is a pressure and temperature relationship problem, we are tasked to find the new pressure. Using the formula P sub 1 all over T sub 1 is equal to P sub 2 all over T sub 2, we will now get the new pressure. P sub 2 is equal to P sub 1 times T sub 2 all over T sub 1. Then substitute the given, wherein the given are 922 millimeters mercury, which is the pressure 1, and 122.78 Kelvin, which is the temperature 2, all over 300 Kelvin, which is the temperature 1. Then we will get the answer 376.53 millimeters mercury. The fourth problem is all about Avogadro's law. If 0.75 moles of argon has a volume of 17.0 liters, calculate the volume of 1.65 moles argon. Using the formula V sub 1 all over N sub 1 is equal to V sub 2 all over N sub 2. In order to find V sub 2 or the second volume, we must multiply V sub 1 times N sub 2 all over N sub 1. Then substitute the given. 1.65 moles of argon multiplied to 17.0 liters all over 0.75 mole of argon. We will get the answer 37.5 liters. The last problem is all about ideal gas law. Calculate the volume occupied by 0.96 moles krypton under a pressure of 5.77 atmosphere at 490 Kelvin. Using the formula to find the ideal gas law, P times V is equal to nRT, wherein R is equal to 0.821 liters atmosphere all over moles Kelvin. The given R, 0.96 moles of krypton is equal to N, and 5.77 atm or atmosphere is equal to P, and 490 Kelvin is equal to T, and the gas constant or R is equal to 0.0821 liters atmosphere all over moles Kelvin. In order to find volume, we must multiply N times R times T all over P. Then substitute the given. 0.96 moles krypton multiplied to 0.0821 liters atmosphere all over moles Kelvin times 490 Kelvin all over 5.77 atmosphere. And the volume is equal to 6.69 liters.